You are tuned to Iri-e-learning, and I am your host, Teacher. This States of Matter lesson is on solid, liquid, and gas. Check the description box for the links to all the videos for this unit. By the end of this lesson, we should be able to name the three states of matter and compare the properties of the three states of matter. What are the three states of matter? Matter exists in three states: solid, liquid, and gas. Now we're going to compare some properties of the three states of matter, and the properties we're going to be focusing on are the arrangement of the particles, the energy of the particles, the strength of the interparticle forces, that's the force that holds the particles together, the movement of the particles, and we're going to look at some physical characteristics, particularly shape and volume, compressibility, and density. So we're starting off with the arrangement of the particles, and already we have three diagrams representing the arrangement of the three states of matter. And of course, our first one is solid. And as you can see, the solid particles are closely packed in an orderly fashion. Next, we have liquid, and liquid particles are randomly arranged with spaces between them, between some of the particles. And of course, some particles may actually exist as clusters and not individual liquid particles. Then we have gas, and gas particles are far apart and they do not stick together. So the particles exist as individual particles, as we can see here. They're not clustering as in the case of the liquid. Neither are they touching or closely packed as in the case of solids. Next is the energy of particles. The particles of solids have very low energy. As a result, solid particles do not move around. They only vibrate in a fixed position. Liquid particles have more energy than solid particles, and the energy of the liquid particles is described as moderately weak. Gas particles have very high energy and they move around rapidly. Now we're looking at the strength of the interparticle force. For solids, as you can see, the solid particles are sticking together. So that should tell us something about the interparticle force. What kind of strength force will hold the particles close together? And therefore, we know that solids have very strong force of attraction between the particles. In other words, their interparticle force is strong. Liquids have moderate to weak forces of attraction between particles. And gas particles have very weak interparticle forces, and the reason why the particles spread far apart. Moving on to the movement of the particles. Now, solids, they are closely packed. They're confined within their space. And as a result, these particles are only able to vibrate in a fixed position. Liquids, on the other hand, the particles have random motion and can move past each other. And of course, with gases, they have a wide range of movement, which is random and haphazard. There's no particular order to how these particles will move in the gas state. Now, just to give you an idea in terms of the movement, so that you can have a visual, I should say, solids, they vibrate in their fixed position. As we can see here in our animation, the particles are only vibrating because they don't have enough energy to move away and to move around. Liquids, in their clusters, sometimes they're moving around and they can flow past each other. While gases, they're randomly moving all over. And of course, you can see that they also have very high energy because the particles are moving quite rapidly as well. Now, looking at the comparison of the physical characteristics, we mentioned that we would have been looking at shape, volume, density, compressibility, not necessarily in that order in which I have listed them. So let's just go ahead. So we're going to look at the shape and the volume of solid, liquids, and gases. And for solids, they keep their shape and volume. So whatever shape, if you have a pen, no matter where you put that pen, if you put it on the table, if you put it on the ground, its shape and volume remain the same. It does not change according to the location where you have placed that pen. The liquids, on the other hand, they take the shape of their container, but they keep their own volume. So if you have 1 cup of water and you were to put it into a teacup, it's still 1 cup of water that you have placed in the teacup, and it takes the shape of that container. If the water is then transferred to a water bottle, the volume remains as 1 cup, although the water takes the shape of the bottle. Gases, on the other hand, take the shape and volume of their container. Gas particles will spread to occupy all the space available within a container, therefore taking the volume and the shape of the container. Compressibility. Compressibility has to do with pushing the particles closer together. As we can see from our particle arrangement diagram, the particles of the solids are closely packed. They are actually touching each other. Therefore, there isn't any space between the particles to push them any closer. As a result, solids are not easily compressible because the particles are held close together. Unlike solids, liquids have some spaces between the clusters of particles, which means these clusters of particles can be pushed closer together. Therefore, liquids can be compressed slightly due to the existence of some space between particles. Gas particles have a lot of space between them, and as a result, they are easily compressed. Next, we have density. Density has to do with the amount of particles within a given space. The more particles within a given space, the greater the density. The opposite is true. The fewer the particles in a given space, the lower the density. Note in our illustration, the 3 boxes are of equal sizes. However, solids have a lot more particles within their given space, and as a result, solids have very high density. Gases, on the other hand, have very few particles within that given space compared to liquids and solids, and as a result, gases have very low density. Liquids, on the other hand, have medium to high range densities. The lesson summary points include solid, liquid, and gas are the 3 states of matter. Solid particles are closely packed due to very high interparticle forces. Solid particles have low energy and vibrate in a fixed position. Gas particles have maximum spaces between them due to very weak interparticle forces. Gas particles have very high energy and move rapidly. Gas particles take the shape and volume of their containers. Liquids take the shape of their containers, but not the volume. Liquids and gases are compressible while solids are not. Solids have very high density and gases have very low density. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. In what state does matter exist? A. Solid. B. Liquid. C. Gas. D. All of the above. And the answer is all of the above. And I'm sure you can give yourself a pat on the back for getting the correct answer. Question 2. In which state of matter do the particles have the most energy? A. Solid. B. Liquid. C. Gas. D. All of the above. And the answer is C. Gas. Question 3. Name the state of matter that takes the shape but not the volume of its container. A. Solid. B. Liquid. C. Gas. D. All of the above. And the answer is liquids. Liquids take the shape of their container, but they do not assume the volume of their container. They maintain their own volume, or it's said that they have a definite volume. Question 4. Which states of matter assume the shape of their container? A. Solid and liquid. B. Liquid and gas. C. Gas and solid. D. None of the above. And the answer, of course, is B, liquids and gases. So a liquid and a gas will take the shape of their container. Question 5. Identify the state of matter for substance X, which has the following physical properties. It's not compressible, very dense, and has a definite volume. A, solid. B, liquid. C, gas. And D, none of the above. And our answer is A, solid. As you remember from the fact that we are saying it's not compressible, solid particles are already close together, which makes it just impossible to push those particles any closer, and hence they're usually not compressible. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.